Hello class, and welcome to our lesson on wave behavior. Look at the images that you see here on this slide. You have a dog staring in a mirror, a pencil appearing to be broken in a glass of water, and being able to see different colors, such as a red apple. How does this apply to waves? Well, in this video lesson, we're going to discover some different behaviors of waves, which allows the phenomena that you see here on this screen to occur. There are 5 specific types of wave behaviors that we will discuss in this video lesson, and they're all listed here on our slide. We're going to be looking at reflection, refraction, diffraction, absorption, and transmission. Let's first talk about reflection, which is probably the wave behavior that you are most familiar with. Well, what happens whenever we are able to see reflections in the mirrors? Well, reflection occurs when a wave strikes an object or surface and it bounces off. Light waves are produced by a source of light that bounce off of your face. So whenever I'm looking in the mirror, there has to be a source of light in order for me to be able to see my reflection. The light will hit the source of light will bounce off of your face. It strikes the mirror and then it reflects back to your eyes. Sound waves can also be reflected. That is when we are able to hear echoes. So reflection is a wave striking an object or a surface and bouncing off. And you have several examples here that shows how reflection occurs. Reflection can occur with light as well as with sound waves. Refraction. Refraction is when waves travel from one medium to another, and when they do that, they bend. Remember in our discussion on last week, we talked about when waves travel through different mediums, their speed can change. For example, when sound waves travel through solids, they travel much faster than versus if they're traveling through air. Light waves, however, they travel faster through air and they travel slower through solids and liquids. So here on this screen, when we're talking about refraction, it has a lot to do with the speed of the wave changing as it changes mediums. And when it does that, it causes us to see images as they really aren't. For example, when I put this pencil in this glass of water, and I'm looking at it with my eyes, which I'm able to see because of light waves, the light is traveling through different mediums. And as it does that, the speed of the wave changes. So it makes things appear as they really aren't. So this pencil here appears to be broken, but if I were to pull this pencil out of this glass of water, of course it's not broken. I see that because of what we call refraction. It occurs when the speed of a wave changes as it passes from one substance to another. When a light wave passes from air into water, it slows down and bends because we said that waves, light waves, which are electromagnetic, they travel faster in air than they do in water and solids. So as it's moving from air down into the water, it's going to slow down, and when it's doing that, it's going to bend. Sound waves, they speed up as they pass from air to water because they are going to travel, sound waves are going to travel faster in substances that are more dense. So if I'm going from air, which is not very dense at all, to water, which is a little more dense, then that sound waves is going to speed up. Sound waves can also bend as they move through air of different temperatures. We can see down here in this picture, you've got cooler air, and you've got warmer air, and you can kind of see how it bends as it goes through different airs of different temperatures, and that's because of density. Warmer air is going to be less dense than cooler air, okay? So you can kind of see how it bends here as it's going through different temperatures, all right? Diffraction. Diffraction and refraction are closely related in that they both involve the bending of waves. However, diffraction is the bending of a wave around a barrier. A barrier is something that's in the way of the wave, and the wave is able to bend around that. The amount that a wave will diffract, it depends on its wavelength and the size of the barrier or the opening. Light waves have very small wavelengths. Remember where visible light is found on the electromagnetic spectrum. It's found on the end where the wavelength is starting to get much shorter. So they have a very small wavelength. So therefore, they cannot diffract or bend that much around very large obstacles, such as a building, okay? However, sound waves can. Sound waves have much longer wavelengths, and they can bend more around obstacles, around larger obstacles, more than light waves can. That's why if I'm sitting at my desk and I can hear students in the hallway long before I'm going to be able to see them, and that's because those sound waves are diffracting more than the light waves. Here are a few picture examples here of diffraction. This is a basic picture that kind of shows you what happens with diffraction. You've got your waves. This red part is your barrier, and as they try to go through this barrier, they bend. Okay? And these are two examples of light and sound. Whenever you have clouds in the sky, but we can still see the sunlight, the light is able to bend around those clouds. And then here, this is the example of a sound wave being able to bend around a barrier here. This wall is the barrier, okay? And then you've got, of course, a radio. And the person here, the boy, would be able to hear the radio around this wall, the sound, because the sound waves are going to bend around this barrier, okay? So two examples here, two real life examples of how light and sound waves can bend, and then this is a basic picture that shows what happens with diffraction. So remember, refraction and diffraction, they both involve the bending of a wave. Refraction is when waves bend as they go through different mediums, and then diffraction is when waves are bending around some type of barrier. All right, let's talk about absorption next. When you think about the word absorbed, you may think about something being taken in. Well, that's what happens with absorption and waves. Absorption is the disappearance of a wave into a medium. Because of absorption, we are able to see different colors. That's how we're able to see different colors. The color of an object is determined by the wavelength of light that it will absorb and those that it reflects. For example, when we see a red apple as being red, that's because all of the colors that make up the visible light spectrum, which we have a picture of in our notebook, is going to be absorbed by that apple. Red is the one that gets reflected. So that's why we see the apple as being red. Remember when we were studying the electromagnetic spectrum, visible light has a spectrum of its own. Remember we use the mnemonic device Roy G. Biv, which are letters that represent all the colors that make up visible light. So whenever we see different colors, the colors that we see are the ones that are getting reflected. And then all of the other colors that make up visible light are the ones that are being absorbed by that object, okay? Here's another example, banana. We see it as yellow because all the colors of visible light get absorbed by this banana except yellow. Yellow is what's reflected, so that's what we see. Sound waves can also be absorbed. This right here is an example of a wall that has sound insulation in it. This is how you would make a room that is soundproof. You would put insulation in the wall that would be able to absorb those sound waves, and therefore that is how sound waves get absorbed, okay, is through this insulation. And you may not be able to absorb all of the sound because you can see here in this picture that some of the sound gets reflected, and then you also have some sound that is outgoing sound. But you can see right here where the sound can be absorbed here by this insulation. But it's just the disappearance of a wave into a medium. So the medium will absorb that wave and it kind of just stays there, okay? But that's what we call absorption of waves. All right, our last one is transmission. Transmission, I don't want you to get confused with refraction, because if you look at the pictures here, you can kind of see the wave is going through a medium, but with transmission, it's the passing of a wave through a medium. So it just goes straight through that medium. It's not bending or anything. When light is transmitted by an object, we see the color of the transmitted light wave, kind of like what we were talking about in the previous slide. So you can see here in this picture, you've got sunlight. It goes through this glass, and this is what we would call transmission. You also have some light that would also get reflected, which is why we can see our images on a glass. If you were to walk by a glass window, you can see your image in that glass window. Sound can also be transmitted as well. Right here, this remember from the previous picture where we saw the sound insulation, and we saw some of it was absorbed, but some of it kind of went straight through. Well, the waves that went straight through, we would say they were transmitted, okay? So transmission is the passing of a wave through a medium. All right, let's look back at the 5 types of wave behaviors that we discussed, and we're going to kind of summarize them on this slide, looking at these different pictures here. You can see that transmission, you've got the wave going through the medium. Reflection is when a wave hits a surface or object and bounces off. Refraction is when the wave will bend as it goes through different mediums. Absorption is when the wave will kind of disappear into the medium or be taken in by the medium. And then diffraction is the wave bending around a barrier. Okay, so these are all of the different types of wave behavior. Use this slide to get any pictures that you did not get on your graphic organizer, because these are some basic kind of pictures that shows you what's happening with these different types of wave behaviors. Make sure you have completed your graphic organizer and you have all of your notes. And that concludes our lesson, our video lesson on wave behavior. Yeah.